find dy dx using implicit differentiation. So you have x squared plus 3xy squared minus 5y cubed equals to 19. Now one way to do this would be to solve this equation for y, but that's nearly impossible. It's very, very hard to solve this for y. That's why we have to use implicit differentiation, which means you pretend that you know what y is. In other words, y would be, if you solved this for y would be a function of x, right? So you treat x as x, but y would be y of x. Okay, y is a function, whereas x is just x. And there is this asymmetry between the way you treat x and y, and that's why many people struggle with implicit differentiation, because suddenly y is not just y is a function of x. Now what difference does it make? Well, let's see. We differentiate both sides. Differentiate. 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 And x squared differentiates to 2x. There's nothing to worry about. However, when you differentiate 3x times y squared, it's a function 3x and function y squared multiplied together, right? Since y is a function of x that is squared, that's again a function of x. Y squared is again a function of x. So what you're seeing here is a product of two functions, which means you must use the product rule. Okay, so we apply the product rule for this single thing. So this single term produces two terms because we use the product rule. And then negative 5 can be pulled outside and you have to differentiate y cubed prime. 19 prime is just 0. That's easy. Okay, let's continue. 3x prime is just 3. And this is where you have to be careful. Y squared prime is not 2y. See, y is a function of x nested inside a square function. So although this looks innocent, it's actually a composition of two functions. So it's y of x nested inside the square function. Since it's a composition of functions, since there's a nested function there, you must use the chain rule. If you don't use the chain rule, it's wrong. Okay, so you differentiate y squared as a function of y, so it's 2y. But then y is an inside function, which you have to make a copy of. So you bring it outside and you make a copy of it and you differentiate that. So this y prime appears whenever you differentiate a function of y only. Okay, and that's the asymmetry I'm talking about. If you differentiate a function of x only, it's you just differentiate as usual. But whenever you have to differentiate y squared, y cubed, whatever, then this y prime has to be attached because of the chain rule. So they're asymmetric. The way you handle x, the way you handle y are different. Okay, same thing here. 3 comes down. 3y squared is by the power rule, but because it's a function of y, and y is a function of x, there is a chain rule which says the inside function, the y, has to be pulled outside and you have to differentiate. And that's what you have. And we're not done yet because you still need to figure out what y prime is. So you have to solve this result for y prime. That's another challenge. That's an algebraic challenge that's separate from what we had so far. Okay, so the first mental block is that x and y are treated differently. Second part that's hard is that you have to solve this result for y prime. Okay, y prime is dy dx. We have to find dy dx. So in order to find dy dx, you have to find out what y prime is. Okay, so here I have something that has y prime. Here's another one that has y prime. And what you want to do is you want to separate the ones that have y primes and the ones that do not have y primes. I try to, use the picture for people to imagine, to remember this situation better. It's like y prime is like a t-shirt, and there are two teams playing in the basketball court, and they go shirts and skins. Okay, so the guys without y primes attached, these are like playing in skins, no t-shirts. The guys who do have shirts on, these are the ones with y prime. And now because they have to play a game, they have to be on the two other half of the court. So the middle of the court is like the equal sign. On one side, 2x plus 3y squared, the shirtless guys are there. On the other side, these things have to move. Whenever you move a term, they get the opposite sign. So plus 3x 2y y prime will be minus 3x 2y y prime. And then minus 5 3 y squared y prime would be 5 times 3 y squared y prime. Let's simplify this. This is times, not squared. 3 times 2 is 6, so it's negative 6xy y prime. 5 times 3 is 15 y squared y prime. And the only reason why you want to factor the y prime is because why you want to have the y prime on one side is because you want to factor the y prime out. Then here's the result. You have 2x plus 3y squared on one side. On the other side is something times y prime, and the goal is to isolate y prime, right? So you divide both sides by negative 6xy plus 15y squared. And therefore you have y prime equal to 2x plus 3y squared over negative 6xy plus 15y squared, which is dy dx, right? All right, so it's a lot of work, but there is no other way to find dy dx because the equation given is so complicated. All right, let's try to do the same thing for the second one. Y is 3x minus 5y over 4x plus 3y. You could differentiate both sides as it is, but that's going to give you a quotient rule, and I hate quotient rule. So one nice thing about dealing with an equation rather than a function definition is that since you have an equal sign, you can just multiply the denominators both sides to get rid of the denominators. So what I'm going to do is multiply 4x plus 3y both sides. So that the denominator gets cancelled, and now you have something simple to work with. Let's multiply this out. You get 4xy plus 3y squared equals to 3x minus 5y. And we differentiate everything. So 4xy gets differentiated, 3y squared gets differentiated, 3x gets differentiated, 5y gets differentiated. And all of these, when you differentiate, remember y is a function of x, right? So it's 4x prime times y plus 4x times y prime plus 3 is a constant multiple, so we can take that out and differentiate y squared. 3x prime is just 3, that's easy. And 5, and then y prime is what? Y prime is not 1. Y is a function of x, so if you differentiate y by x, you get y prime. See, this prime here is d dx. You're differentiating by x. So if you have y and you're differentiating by x, it's still a y prime. It's a derivative. You get a derivative. You don't get 1. Okay. Now let's continue. 4x prime is 4. And then 4x, again, y prime is y prime. Plus, and then y is a function of x nested inside the square function, so you have to use the chain rule, which says is 2y, but you have to attach the y prime because that's the derivative of the inside function, equals to 3 minus 5y prime. Okay, let's now identify the shirt guys, the terms with the shirts, and the other guys are shirtless. That's 3 against 2, it's a little unfair. But anyways, 3 goes to this side. You have to move all the shirtless guys on one side, and all the people with the shirt should be on the other side. And make sure you negate whenever you move over the equal signs. 3 times 2 is 6, so it's 6y prime minus 5y prime. So now I've separated the ones with y prime and the ones without y prime. And the reason you want to do this is because you can factor the y prime out. And the result is negative 4x minus 6y minus 5. And finally, you divide both sides by negative 4x minus 6y minus 5. And the result is that y prime is 4y minus 3 over negative 4x minus 6y minus 5. You can further simplify this by pulling the minus out, but that's about all you can do. Fx and gx are 2 differentiable functions whose values are given in this table, and you're given this h of x, which is a composition of 2 functions, and p of x, which is fx to the 4th power, and find h prime of 2 and p prime of 3. Okay, it's similar to other questions that we've done before, where you're not given the formula for f and g, you're just given the values, and you have to figure out just by differentiating and then plugging it. Okay, it's a nested function. G of x is inside f of x, so you differentiate the outside function, pull the inside out and attach it, and therefore h prime of 2 would be f prime of g of 2 times g prime of 2. Now what's g of 2? Let's see, g is here. At 2 it's negative 1, right? So we know that g of 2 should be negative 1, f prime of negative 1. What's g prime of 2? G prime is here, 2, and it's positive 4, so we need positive 4, okay? So delete this, positive 4. And then f prime of negative 1, f prime's here, negative 1 is here, so f prime of negative 1 is 2, so we know that should be 2 times 4. I should delete that just a minute. Okay, it's equal to 2 times 4, which is 8. Now let's do the same thing for p of x. P prime of x would be f of x to the 4th power prime, where f of x is now the inside function, right? So think about f of x as like a big X, x to the 4th differentiates to 4x cubed, but that big X is f of x, right? So it's 4 f of x cubed times you make a copy of the inside function and you differentiate. Therefore, p prime of 3 is now 4 times f of 3 to the cubed times f prime of 3, and f of 3 is 2, so it's 2 cubed. F prime of 3 is negative 2, so that's negative 2. That's 8. 8 times 4 is 32, times 2 is 64, so negative 64 is the answer. A ship sailing in the middle of the Atlantic has 1,000 tons of bunker fuel at 1 p.m. That same day at 5 p.m., the ship had 920 tons of bunker fuel in the tank. Find the average rate of change of the bunker fuel in that time period. Okay, so average rate of change is change of the quantity, that's the dependent quantity, over change of time. Okay. And the dependent quantity that's changing with respect to time is the bunker fuel, right? So we're trying to find the bunker fuel change of the bunker fuel over the change of time. The times are 1 p.m. and 5 p.m., right? And whenever you measure the change, it's always the final value minus the initial value. So your final value, 920, should be written first, minus the initial value, which is 1,000. And the unit for this is tons, right? And then the final value of the time is 5 p.m. The initial value of the time is 1 p.m. So subtract, and this is in hours. So you end up with negative 80 divided by 4, which is negative 20 tons of fuel per hour. So negative means the fuel is decreasing. Of course, you're sailing, so fuel must be decreasing. And you're using about 20 tons of bunker fuel per hour. Okay, if the ship went 120 nautical miles in that time period, what is the average rate of change of the bunker fuel with respect to the distance covered? Okay, so again, it's the average rate of change, but it's with respect to a different value. It's with respect to the distance covered. So here in B, it's change of the bunker fuel with respect to change of the distance covered. So I'm going to use X for the distance covered. Again, it's the final value minus the initial value divided by the final, what's the distance covered? I mean, this is a change in the distance or change in the position. And since it covered 120 nautical miles, the change in the position must be 120. Right? So you end up with negative 80 again over 120, and if you simplify this, it's 2/3, so it's negative 2/3. The numerator has a unit of tons, and the denominator has a unit of miles. Now in decimals, this will be negative 0.667. It's rounded up from the to the nearest thousands, so it's like 0.667 tons of bunker fuel for every mile. That's how much this ship is using. Find the equation of the line tangent at 2, -1 on the graph of this function. Okay. All right. So you need the equation of the line, which means you need to use the point slope form. Now, in order to use the point slope form, you need to know the slope and x naught, y naught, but that's easy, that's already given. X naught is 2, y naught is -1. So you just have to know the slope, but the slope of the tangent line is the derivative. So m would be dy dx evaluated at 2, -1. That's how you get the slope. However, you have x and y given as an equation, and trying to solve this for y would be very hard because it's a quadratic equation for y. So rather than trying to differentiate this after solving for y, we're just going to differentiate it as it is. But that means you're trying to solve the derivative implicitly. So that's what this question is really about. It's about using the implicit differentiation to find the derivative implicitly, and then you use that to find the slope. Okay, y squared prime is 2yy prime. 4x and y, that's 4x prime times y plus 4x times y prime plus 3 comes down, that's 6x squared. 9 is a constant, so that just gives you 0. Okay, 2y prime, 4x differentiates to 4. Y prime is y prime, it's not 1, it's y prime, be careful, because y is a function of x. Basically, implicit differentiation treats x and y differently. Y is a function of x, whereas x is just a variable. Okay, and then because I need to find out what y prime is, I have to identify the ones that have y primes in there. And the ones that do not have y prime should go to the other side. So I'm separating the two. And you don't have to do this, but I see that 2, 4, 4, 6, they're all divisible by 2. So let's just divide by 2. It's not necessary, but it makes our life easier. Okay? And then divide, factor the y prime out, giving you y plus 2x equals -2y minus 3x cubed. divide, and you get y prime equals to negative 2y minus 3x cubed divided by y plus 2x. Perfect. So that's our y prime. That's our dy dx. Now, I've said derivative is the tangent line slope so many times that many people think that this is the slope of the tangent line, but it's not. It becomes the slope of the tangent line only if you evaluate it at the given point. So here's 2 comma negative 1, and this means x is 2 and y is negative 1. You have to plug in those values into here in order to get the slope. So the slope would be negative 2 times what? Y is negative 1. You plug in negative 1 for y. And then minus 3, and then x is 2. And then y is negative 1 plus 2 times x is 2. So you get 2 minus 3 times 8, that's actually 24. 2 times 2 is 4. 4 plus negative 1, that's positive 3. So you end up with negative 22 over 3. So I have the slope, I have the points. So what is the answer? Oh, I'm running out of space, so let me write the answer here. You end up with y minus y naught is negative 1, so negative 1 equal to m negative 22 over 3. Worked so hard to get that, right? And then x minus 2. And you solve this for y in order to get the slope-intercept form. So multiplying this, you get negative 22 over 3 times x. Multiplying this will give you plus 44 over 3. But then you subtract 1. This is plus 1, right? So if you move it, it's minus 1. So your final answer is negative 22 over 3x plus 41 over 3. And that's the final answer. A street light is mounted at the top of a 15 feet tall pole. A man 6 feet walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of the shadow moving when he is 40 feet from the pole? Okay, it's very important to understand what's going on by drawing a picture. So here's a street light, and there's a man, and let's draw a stick figure. Here's a man, and he's going away from the pole at certain speed, 5 feet per second. And then it's going to give you a shadow, right? The shadow will be like you have this light coming from there, and therefore you're going to get this shadow here, shadow, right? And you're trying to figure out how fast is the tip of the shadow moving. So it's not asking for how fast the shadow is increasing. That's also going to happen too, right? As he moves away, the shadow is going to get bigger and bigger. But this will be always ahead of this man, and it's probably going to get away from the pole faster than 5 feet per second. And that's something nice to know. Your final answer better be bigger than this number 5, okay? Alright, so now how do we actually solve this? Well, we need a simplified picture, so let's draw a simplified picture. Very simplified geometry, that's what we need, okay? So don't draw stick figures, just think about the length, the height of the man, which is just 6, and the pole has the height 15. Now I'm putting these numbers down because these are never changing. 15 and 6 are never changing. But see this 40? It's asking what happens when he's 40 feet away from the pole. That should never be put in here because that's a changing number. As he walks away, this distance between the man and the pole will be bigger and bigger, okay? So you should never do that. And it's asking for how fast this point is going away from this pole. So really this distance, I'm going to call that x, that's what's needed. Okay, x is what's needed. And another thing is that we need to know this distance, which is y. That's because 5 feet per second, what's that? That means this distance is changing, right? So dy dt is 5. And that's why we need to put this y there, okay? So you have two right triangles, and you need two lengths. This length, x, rate of change of x is what I need to know, and rate of change of y is what's given, okay? So the question is, what is the x dt when he is 40 feet from the pole, so y is equals to 40. That's the question. Okay, now you have triangles, two triangles. A lot of times when you have a right triangle, it's just the Pythagorean theorem. But here, the hypotenuse is not really involved, right? It's just these two lengths. So what you need to do is, since you have two triangles, you have to think of in terms of ratios of triangles. See, this small right triangle and the big right triangle, these are similar triangles. So there's a ratio between the two. And you can say what 15 is to x in the big triangle. So in the big triangle, the height is 15 and the base is x, right? In the smaller triangle, it's what 6 is the height, and what's the base? Well, the base is this length, but that's like x minus y, right? So you can do some geometry to see that it's 6 over x minus y. This happens to be a very famous problem. I think I have like a couple of other videos that I do this, and there are many other YouTube channels where they solve this. So and this is just one way to solve it. So I would encourage you to look for other videos with a street light and street lamp or street light and some guy like moving away. Some questions have shadow lengths. Some people want just the tip of the shadow speed. Some people also want the rate of the shadow increasing and the tip of the shadow, both of them. So there are many variants, and I would encourage you to look for other similar problems and see how they are solved, because it really helps if you see this many times. Okay, so so I have this, and this equation basically captures this picture. Okay, and that's all you need from this picture. So now what I have is, I started from this picture, I made a simplified picture, and I wrote down what it means, and I got an equation from the picture, and this is all I need. This is everything from the equation, from the original problem. Once you have these equations, then you don't even have to think about the original problem. Well, maybe in order to write the answer and interpret the answer and write down the units, you might need to go back. But for now, you just have to focus on these things. Okay. Now, basically, related rates, once you have the relationship, it's like doing implicit differentiation, except that this time both x and y are functions of t. So in some sense, it's easier than implicit differentiation because both x and y are treated equally. Okay? They're both functions of t. So you have to use chain rule many times. Now, another thing that you can think about is, although this is an equation and you can just differentiate both sides in this format, it's better to just simplify first by doing the cross multiplication. You know how to solve ratios, right? You do cross multiplication, right? You do cross multiplication to get a simpler equation, which is 15 times x minus y equals to 6x. That's easier to differentiate, so let's differentiate both sides, which gives you 15 times x prime minus y prime. None of these are 1, okay? X is a function of t, and this prime means differentiation by dt, okay? So it's the derivative of x with respect to t. That's what this means. Do not write 1. wrong. So x prime minus y prime and 6x prime. And since y prime, this is y prime. See, dy dt means y prime. So this means y prime is 5. We can just now replace this by y 5. And let's see what we have. 15 times x prime minus 15 times 5 equals to 6x prime. 15 times 5 is 75, so I'm going to move it over there. 6x prime moves here, so you have 15 minus 6, which is 9x prime, equals to 75. And therefore, x prime would be 75 over 9, which is 25 over 3. And what I just got here is dx dt equals to 25 over 3. See, x prime is dx dt. Now, usually what happens is this will be a function of x or y or t or whatever, and you have to get this next information involved, that y is equal to 40. So you have to plug in y equal to 40. But it turns out, since this dx dt is a constant function, even if you plug in y equals to 40, it will still become 25 over 3. Okay. Yeah. So it's it just happened that way. In many cases, you still have to have this involved, but here it ended up being not necessary. Okay. So you have this, and all of these application problems, word problems, you have to write down the proper unit, or else it's not correct. So because the speed is measured as feet per second, and this is the speed of the tip of the shadow, the answer should be feet per second.